Hey guys, this is Vikas back with a new tutorial on how to make a vinegar battery. This is based on a simple fact that when two different metal electrodes are immersed into an acid, it creates a flow of electron. So we'll be using two different metals and dip it into vinegar, which is 4% acetic acid. Use the DC type of voltage to glow a LED bulb. What you'll need for this experiment are vinegar, a multimeter, digital multimeter, to record the voltage. We'll need this for bench testing, it is optional by the way. Galvanized nail, an LED bulb, preferably a red one because it requires a less voltage than the white ones, a small container, a marker, a few jumper cables. This is I have prepared on my own to secure the connection, and adhesive tape and a refrigerator ice tray, an earthing wire as well. This will give you, if you peel this off, it will give you a copper wire which can be used as a metal electrode. So first we'll be bench testing it to see how much the voltage is. So for that, the first step is to fill the container with 3/4 of vinegar and then attach an adhesive tape as shown in the video. So we'll make two holes with a screw, and here zinc acts as an electrode, that is two different metals. Okay, so we have immersed zinc into the acetic acid. The next step is to bend the copper wire as shown. This will prevent falling it inside, and we'll just dip it into the vinegar acid. Just connect the jumper cables to the terminals. Let's check out the voltage. So we'll turn it on and connect the terminals with the multimeter input. So I've connected randomly, and let's see what the voltage is. It's 0.8889, and notice that there is a minus sign which indicates that we have connected the leads to the opposite side. So we'll just revert the leads and see what happens. So it's giving plus 0.99 volts, that is approximately 1 volt. So I guess 4 such compartments would be necessary to make an LED glow. So let's mark it, the positive terminal with positive and negative with negative. Here zinc nail is the negative terminal and copper is the positive terminal. We'll just write it down so that we don't forget it. 1 volt output from one cell, so we'll require 4 volts from 4 cells. So the next step is to wind the copper wire to the zinc nail like this. Do this with 4 or 5 different nails like this. Now pour vinegar in 4 cells of ice tray like this. And we'll just mark it as cell 1, 2, 3 and 4. So these are the positive negative terminals for our reference. Dip the zinc and copper wire. Zinc nail is the negative and copper is the positive, so we'll just dip it down. The negative, that is zinc, goes into the first cell, and the positive part of it goes into the second cell, right? So we know that electrons flow from negative to positive, so it will flow from cell 1 to 2. Then we'll put the negative into the second cell and connect it with the third cell with the positive. Okay, so the current has been added over here. Since this is a connection in series, the electrons flow from second to third, and now we'll dip the nail in the negative third cell, and which will give the flow of electrons from third cell to fourth cell. Okay, and then the output. Let's check out the output. It's 2.9496, approximately 3 volts, and I think that would be enough for us to power one single LED bulb. Before we proceed, you got to know something about the LED bulb. This work on DC type of voltage, and there is a positive and negative terminal. There are two legs. One is shorter than the other. The shorter terminal is actually your negative terminal, and the longer terminal is your positive terminal. We'll just put it inside the vinegar battery and see what happens. Note that the positive terminal into the first cell, the negative terminal should go into the fourth cell. Let's see what happens. Okay, it's glowing, you can see that. And we'll just, you can see, just to be more clear, we'll switch off the lights, and you can see it is glowing. We'll turn it on. We'll again switch off and see. Okay, so it's glowing, and we have done our project successfully. Thank you, and do subscribe.